Welcome to the session 2 of the Unit 5 of our financial modeling course. In this session, we are going to consider modeling of time series and also its properties. By the end of this session, you should be able to do the following. That's one, you should be able to explain the nature of time series model, and also you should be able to state the desirable characteristics of or properties of time series for modeling. There are basically two types of time series model. These are models relating to current values of a time series, where we consider the past to predict the future. Here we consider, or we call them, the ARIMA models, or what we call the autoregressive integrated moving average models. So here the hope is to use the past data to be able to predict the future. So we're able to use past values to predict future values. Here the current values is simply the endogenous variable, and the past values and errors are the exogenous. So by endogenous, we are looking at values that we can predict internally or we can deal with internally, and exogenous are simply variables that are outside our domain, so we cannot estimate them. By endogenous is variables that we have control over. And also we have the second type of the time series models are the linear regression models, which are used in time series. This is widely used, although certain assumptions of linear regression models are mostly violated in our model estimation. Characteristics of time series. In dealing with time series, we have to look for specific behavior patterns in data, and these are what we refer to as the characteristics of the time series. Some of these important characteristics are the trend. The trend is simply a tendency of the time series on average to increase or decrease over time. And also we have seasonality. We have to ask ourselves as to whether there are regularly repeating patterns of highs and low related to seasons, or whether there are some days of the week effects, months of the year effects, among others. So we are looking at the continuous patterns, or the patterns that repeat itself over time. And we have outliers. So by outliers, we simply look at the extremes, or where there are among data set, where there is a particular data set that has a different, or that forms that falls far apart. That is, when we plot a particular data set, that is data series or return series of particular asset class, and we see that there are some variables that are found outside, or that are found far off the center, we consider them as outliers. And these are some of the observations that have the tendency of influencing the regression analysis or the result of our regression model. We have the long run cycles. With the long run cycles, we are seeing that there could be long run or short run cycles, or we are talking about long run cycles which are unrelated to seasonal factors. So for example, we are looking at a sustained economic growth followed by the long recession in Japan in the 1990s, or we will look at some of the impacts of the global financial crisis, among other factors. We also have the variance. The variance is simply the variations in the data set, or even in the error term. So the nature of the variance tells us a lot about what happens in the past and what is going to happen in the future. And also finally, we have the abrupt changes or regime switching. So the phenomenon for which we have the observation can change from one state to another state. It could be temporarily or permanently. So with the regime switching, we are looking at how patterns of movement within a data set or within a particular market changes over time. And we are saying that where the change is permanent, we have what we call the structural change. We have already dealt with issues of structural change, where we have the child test that is being used to see whether there are breakpoints within the series. And also structural changes are common in economies which undergo fundamental changes. For example, a purely agrarian economy that changes to a technology-based economy producing high net worth technological equipment will see its GDP rise sharply and remain at that level over time. On the other hand, stock market return undergoes regime switching, cycling through phases of low and high volatility. So we are seeing that with regime switching, we could either have a long term, which is termed as structural change, or otherwise. The composition of time series. By the composition, we are simply referring to a statistical task that deconstructs a time series into several components, with each component representing one of the underlying categories of pattern. So we are saying that any time series can be decomposed into its component, namely a trend, seasonality, and errors. Decomposition enables us to visualize the main contributors to the series. That is, decomposition can either be additive or multiplicative. So the equation we have here is simply a sample additive decomposition where yt is equal to ct, which is the trend, st, which is the season, and the et, which is the error, respectively. So here we are talking about time series because the subscript is t, and we are looking at the all various of the composition or the components of the composition of a time series. Figure 1 is simply an additive decomposition of the Ghana Stock Exchange Composite Index, where the dataset has been decomposed into the various series or the various components, including the residual or the error, the seasonal, and also the trend. So this is the overall observation. So you see how the trend moves, and so with the first observation, we are looking at the raw data without it being decomposed, and you could see the patterns. You can you hardly you can hardly tell as to what really causes the movement in this price series or return series. So by decomposing this data into its significant components such as the errors, seasonal, and trend, we will now see that these patches are no longer patches, but the trend has become very clear to the eye, and we can see how the trends moves. And also the seasonal, we are now looking at the seasonal effect in the trend. So meaning this same observation, there were this trend which was somehow smooth, and also there was this seasonal effect or seasonal patterns which was forming, or which was what really caused or formed the patches or the rough edges of the observation, and we have the residuals all having impact on this observation. So by decomposing the data set, we've been able to now observe the trend as to how the trend moves, how seasonal effects were actually in the observation, and also the residuals. On the other hand, we can have a multiplicative time series model in which the time series is a product of the components. So unlike the additive additive decomposition, the multiplicative decomposition is simply a product. So here we are simply multiplying rather than adding. So similar to the additive, the same graph we have here, like the Ghana Stock Exchange Composite Index, and the same impact or effect is being observed here, where this is the raw observation, this is the trend, this is the seasonal effect, and this is the residual. So we will always ask ourselves, like, how do we know which of these to use in time series, as whether we should use the additive decomposition or the multiplicative decomposition? This is an empirical question. So if we observe that the amplitude of both the seasonal and error variation do not change as the level of the trend rises or falls, then an additive model is an appropriate model of decomposition. But on the other hand, if the amplitude of both the seasonal and error variation increases as the level of the trend rises, then financial analysts have a preference for a multiplicative decomposition or model decomposition. Speaking on the statistical properties of time series, there is a need for us to understand that there are several properties of time series analysis. Consider the Ghana Stock Exchange Composite Index in our diagram, that's figure 3. You could see that unlike the previous one that we had to decompose, this data set has seasonal movement or patterns, they have trend, and also the errors. These are data sets from the Ghana Stock Exchange, that is daily data set, that is from 2000 and January 4th to 19 January 2011, and these are the price series. As we have already established that the price series are not stationary, you could definitely see that there are patterns, season, and all those errors having impact on the price series. Therefore, it is always advisable for us to be able to transform these data from price to return series in order for us to use them for financial analysis or time series analysis. So these are raw data, and a plot of them gives us review to us as to how the trends moves and the up and down movement in the price series. On the other hand, after transforming data from the raw prices to the return series, we're likely to see or to observe that there are changes from the raw figures that were in high figures to these low figures that seems quite stationary. So we could see that after this is an example of log returns that we are where we have found the natural logs of the price series and then we difference them. So these are the log differences of the normal price series. So unlike the price series which has a varied pattern such as the seasonal effects, the trend patterns, and also the errors, you could see that the return series, that is the log returns, rather behave differently. So you could see that the log return has some form of stationarity compared to the price series, which was having this downward and upward trends which were constant over time. So this return series are quite stationary, as we have already established in our previous sessions in the previous unit on the issue of stationarity. So one of the time series property of return is that it is stationary, and that is what we termed as stylized fact in our previous sessions. So in summary, in this session, we have been able to explain the nature of time series model. We'll be able to state the desirable characteristics of time series modeling, where we learn about the decomposition of datasets among others. Thank you once again for your attention as we meet the end of today's discussion. Hope to meet you once again in our next session. Stay blessed.